A persistent problem in technical HCI research is that while we are great at creating artifacts, we rarely share them. Without access to these systems, replication studies are impossible, meaningful A/B evaluations are out of reach, and the field gravitates towards isolated novelty rather than cumulative knowledge. Trying to re-implement a system is challenging and unrewarding. Luckily, agentic programming tools, systems like Claude Code, Cursor, and Gemini, are making re-implementation substantially more tractable. In our work, we introduced the concept of revibe coding, using natural language-driven agentic tools to re-implement a research artifact. We do this based entirely on the source paper with no direct coding. We call the resulting artifact a revibe. By removing developer skill as a variable, our approach establishes a re-implementation floor, a baseline quality achievable from paper content alone. To test the success of any revibe, we introduce the concept of revibability. Revibability attempts to evaluate how well a revibe approximates the original system. It targets interaction fidelity so the re-implementation can serve as a strong baseline. Our pipeline proceeds in three main steps. First, we automatically generate a system-specific revibability rubric. It consists of a structured set of manual interaction tests, each with clearly defined criteria for full success, partial success, and failure. The rubric serves both as an evaluation instrument and later as structured feedback to the agent. Second, we build the first version of the system. We perform an unaided revibe. We provide the paper content to the agentic tool with a standardized prompt, feedback any errors until the system launches, and then ask the agent to compare its implementation against the paper and add any missing features. A grader can then look at the reproduced artifact and grade it using the revibability rubric. Finally, we perform one or more aided revibe iterations. The graded rubric is passed back to the agent with a prompt to fix reported issues. This process can be repeated, with each iteration producing an updated implementation and a new rubric evaluation. To evaluate our approach, we identified highly cited software-focused papers from WIST between 2020 and 2024. After removing papers with public implementations or hardware dependencies, we selected 10 for full revibing. We used three agentic tools through their command line interface, Claude Code, Cursor, and Gemini. For each system, we ran one unaided revibe, followed by 2 rounds of aided revibing, grading the rubric after each round. We can see here how revibability changed for the Spellburst system. Each cell reflects a test, with blue, yellow, and red corresponding to complete success, partial success, and failure respectively. Here are some examples of the output of revibing.
You'll feel like you've got the lay of the land before you.
White flowers.
How many strawberry photos can one have?
All of them. It is.
Across all 10 systems, we saw a mean revibability score of 0.94, with all systems exceeding 0.8 when revived with Cursor or Claude. Revibability improved monotonically across rounds in most cases. Our paper reports on specific performance results and the interesting failure cases we observed in our qualitative evaluation. The results we present are a floor, not a ceiling, as we can expect revibability to improve, especially with human intervention. There are a number of implications of revibing to the technical HCI field. It lowers the barrier to running comparative evaluations, potentially making strong baselines the norm rather than the exception. It could make artifacts evergreen, revivable from their papers long after the original code has become inaccessible. We view revivability itself as a new kind of metric, one that could inform how we write papers, structure supplementary materials, and even evaluate contributions at venues like WIST. Our paper covers these implications and more in detail.